Okay, so this is the first question what I had told you, discussed in the introduction class. Analyze the continuous beam with slope deflection equation, with slope deflection method or equations, and draw BMD SFD. Okay, this is the question. Where now see the conditions. It is a 3-span problem. Previous video I had discussed you what is a 2-span problem. This is a 3-span problem. Span is the support distance. This is a support fixed end, hinged support, hinged, another support at D. So this is the 1 span AB, BC and CD. This is a 3-span problem. Both far ends are fixed. So here in this condition both far ends fixed. Far ends is what? A is a far end and D is a far end. Okay. Now for this purpose, what is the method used? Method is slope deflection method. So in this method I have told you what you need to remember: the equations, slope deflection equations. So basically you should remember what is a slope deflection equation. If you don't know this, you cannot solve the problem. So slope deflection equation for each span, I told you, for each span, depending upon the this notations will change, the formula remains the same. I hope you know what do you mean by notation. So M AB for AB span, for one span AB span, if you take for AB span, the formula is, for one span we'll write down, the equation remains common, only the notations and abbreviation changes. MAB is equal to MF AB plus 2EI divided by L into, open the bracket, 2 theta A plus theta B minus 3 delta by L. So this is the equation for MAB, and MBA is equal to MFBA plus 2EI by length theta A. Now 2 goes that side, that becomes 2 theta B minus 3 delta by L. Okay, this is the equation which you should remember. So by heart these equations. So without this equation you cannot solve slope deflection. Okay, now starting with, we'll start the problem. This is the problem. AB span is given, there is a point load and there is a UDL and there is an unsymmetric point load. So you should know FEM formulas also. FEM. So step 1 is finding out the FEMs. Now I told you what is a step 1. Finding FEMs is nothing but fixed end moment. Okay, fixed end moment. So for fixed end moment, when you consider the fixed end AB span, A, first you should consider AB span and end, both ends are fixed. This is A and this is B. Okay, so for AB span, what is the type of load? Type of load is point load at the center, that is 50. Point load exactly at the center, 2 meters, 2 meters. So how are you going to find out? So at the left hand support, moment induced, fixed end moment induced is anti-clockwise, and the right hand support moment induced is clockwise. Okay, so this becomes MFAB, and this is F is for fixed end, F is MFBA. Okay, now it is a point load. When you have a point load, FEM says MFAB is equal to, so for a point load, a symmetric point load, formula is minus WL by 8. So this is a formula for FEMs, finding out the FEM for the point load at symmetric, minus WL by 8. So minus W is how much? Minus W 50. What is the length? So see, WL by 8 and WL by 4 both are different. WL by 4 is a maximum bending moment at the center when the point load, and WL by 8 is what? Fixed end moment at the fixed end. This formula. So I have discussed, you take the screenshot of the previous class of that formula. So, okay, so these formulas you should remember for point load, for symmetric point load, unsymmetric point load, and UDL. What is the length? Length is 4 meters. This is 8. So 4 ones are 4 twos are 2 ones are 2 25s are, so it will be minus 25. Manually also you can using calci check the answer and then MFBA. What is MFBA? MFBA is positive, so plus W L by 8. So plus WL by 8 plus 50 into what is length? Length is 4 meters divided by 8. So the same thing, it will be plus 25 kilonewton meter. This is your fixed end moment for AB span. Hope you have get it. Similarly, this is for AB span. We'll do it for BC span. First draw the diagram. BC, both ends fixed. This is fixed. UDL is acting. Then this is UDL is 15 kilonewton per meter. Okay, what is the length? Okay, so for BC span, this is the BC. So when you draw the diagram, UDL is acting. So this is left hand side anti-clockwise and this is clockwise. So this becomes MFBC and this is MFCB. So MFCBC and MFCB. So MFBC, if there is a UDL, when the UDL is acting, so the formula is minus WL square by 12. Minus W is how much? 15. What is the length? Length of the member is 5 meters. 5 square divided by 12. So this answer for this. So using calculator, so we have minus 31.25 kilonewton meter. So this is MFBC. MFBC. Now similarly, what will be MFCB? MFCB will be plus WL square by 12. So that will be same, 15 into 5 square divided by 12. So answer for this is plus 31.25. Now for the third span, that is CD, the point load is unsymmetric, that is 80 here, 2 meters and 4 meters, 82 meters and 4 meters. So considering the end X fixed, left hand support anti-clockwise, right hand support clockwise, this will be MFCD and this will be MFDC. Okay, so MFCD is equal to, for n symmetric point load, this is for CD span. Unsymmetric point load, this is unsymmetric point load. Unsymmetric point load, the formula is minus W AB square by L square. Minus 80 into 2 into 4 square divided by L square is 6 square. So use the formula. Okay, use the formula and get the answer. Similarly, MFDC plus W A square B by 80 into 2 square into 4 divided by 6 square. So using calci, you have these values 71.11 and 35.56. Okay, MFCD and MFDC. Now the step 2 is the conditions. What are the conditions you are going to? That is step 2. What are the conditions for the of the given beam? What you should consider in the slope deflection equation. So as I told you, when there is a fixed beam, this is a fixed beam, these are the two joints. We'll enlarge it a little. When the deflected shape of the beam will be like, this is point B and this is C. If if you see the deflected shape of the beam doesn't rotate at the fixed end, it rotates at where the intermediate supports. Okay, at the fixed end it is very fixed tightly, so the beam doesn't rotate. It is held. There is no slope development, and the slope will be developed at B and C. So this is a slope. Slope is the angle. So slope is theta. Here you will have theta. Here you will have theta. Okay. So this is theta B, theta B, theta C, theta C. So here there is no any angle theta. You can see the flat line. Flat line indicates degree is equal to 0. This flat line indicates theta D is equal to 0. Theta, here it is A. Okay, A, B, C and D. Therefore, so theta A is equal to 0 and theta D is equal to 0. Okay, with development of slope at B and C will be there. As the support is hinged and roller, there will be development. For fixed end, there won't be any development of slope. So theta B and theta C exists. Okay, theta B and theta C exists. So what about delta? Is there any deflection? Deflection is delta means any settlement or sinking of any support is. So there is no settlement or sinking of any support given, so it is 0. So delta is equal to 0. So these are the three conditions. First one is theta A and theta D are 0, B and C exist, and delta is 0. So these three conditions you should use in a slope deflection equation. So when you are using slope deflection equation, we will start with the AB span. I have told you what is slope deflection equation. For AB span MAB is equal to MF, this is step 3, MFAB plus 2EI by length 2 theta A plus theta B minus 3 delta by L. So MFAB is how much? MFAB we have calculated. MFAB is minus 25. You can see minus 25 plus 2 EI is constant. EI keep as it is. Length of the member is 4 meters. Length of the member is 4 meters. So theta A, here you should see what are the conditions. Theta A is 0. So theta A is equal to 0. Theta B exists. Delta is 0. So minus 25. 2 1s are 2. 2 2s are 4. 1 by 2 is nothing but it is 0.5, half. So EI multiplied by theta B. So this will be 0.5 EI theta B. So this is your equation 1. Rest all is 0. So 25. This is not 24. This is 25. This is your equation 1. Similarly, you need to make other 5 equations. Okay. So next for span, same span doing for span AB only. MBA, what is the formula? MFBA plus 2 EI by length. So 2 goes for theta B, so here becomes theta A plus 2 theta B minus 3 delta by L. Okay, what is MFBA? MFBA is plus 25 plus 2 EI, length remains same. Theta A, as I told you, theta A is 0 plus 2 theta B minus delta 0. So this becomes 25 plus 2 2s are 4. So 4 divided by 4 will be 1. So EI theta B becomes equation 2. So this is the equation MBA. So next for span BC, similarly write down the equation. MBC is equal to MFBC plus 2 EI by length 2 theta B plus theta C minus 3 delta by L. So MFCB is how much? MFBC is minus 31.25. So minus 31.25 plus 2 EI by length is 5 meters. 2 theta B as it is, theta C as it is existing, this is 0. So 31.25 plus 2 2s are 4, 4 by 5. So this becomes 2 2s are 4, 4 EI theta B divided by 5 plus 2 theta EI theta C divided by 5. So this is your simplify this equation. Okay, so simplifying this equation, we will have 31.25 plus 4 by 5. If you see 4 by 5 will be 5 ones are 5.8 EI theta B plus 2 5, you can see 2 by 5, 2 by 5 ones are 5, so it will be 0.4 EI theta C. So this is the simplified equation, equation 3. Okay, similarly now go for MCB is equal to MFCB plus 2 EI by length theta B plus 2 goes to C now, 2 theta C minus 3 delta by L. Delta always is 0, so you can continue writing 0. MFCB is what? Plus, this is minus plus 31.25 plus 2 EI by length is 5 theta B plus 2 theta C minus 0. So this is plus 31.25 2 EI by theta B plus divided by 5 plus 4 EI theta C divided by 5. So simplify this equation, you will get 31.25. 2 divided by 5 is nothing but 2 ones are to 4.4 EI theta B, and this is 4 divided by 5, that will become 0.85. This 5 is 40. So EI theta, see, this is your equation 4. Okay, this is your equation 4. So MCB and MBC is over. So for span CD, MCD, so MCD formula is MFCD plus 2 EI by length 2 theta C plus theta D minus 3 delta by L. MFCD is how much? Using the formula, you know, MFCD we have calculated, that is for n symmetric. So MFCD, FEM, go for FEM itself. What is your FEM? FEM is 71.11 and MFDC is 35.56. remember this, 71.1. So this is minus 71 point, that is minus. Okay, we have not written minus, but if it is should come here. Minus 71.11 plus 2 EI by length of CD span is 6 meters. 2 theta C plus theta D is 0 minus 0. So this is minus 71.11 plus 2 2s are 4, 4 divided by 6, it will be 0.66 EI theta C. This will be the equation. So going for MDC, MFDC plus 2 EI by length. Now 2 will go to theta D, theta C plus 2 theta d minus 3 delta by length. Okay, so MFDC is how much? I told you to remember, that is 35.56. Value 2 EI by length is again 6 meters. Theta C plus 2 theta D is 0. Theta delta is 0. So this becomes 35.56 plus 2 by 6 is 2 ones are 2, 3 so it will be 0.33 EI theta C. This is equation. This is equation 5 and this is equation 6. So 4 equation was here, 4, this is 5 and this is 6. So we have formed 6 slope deflection equations. After forming 6 slope deflection equation using the slope deflection equation formula, ultimately what we need to find out the moments. So for that, step 4 is equilibrium condition. Now I told you summation of moment at any intermediate joints. Summation of moment at any intermediate joints or the rigid joints, the summation of moment is equal to 0. For example, for joint B and C are rigid joints or intermediate joints. So summation of moment at B should be equal to 0. So this means what? MBA, moment developed at MBA end and plus MBC must be equal to 0. This is the equilibrium condition. Must be equal to 0. This is the equilibrium condition. Similarly, for moment, summation of moment at C is equal to 0. Moment at C will be MCB plus MCD is equal to 0. So these two conditions, applying these two conditions, you will have the equilibrium condition. Using these two equilibrium conditions, you can solve out the problem. You can find out the unknowns. Where theta B and theta C are the unknowns, you can find out those existing values and find out the moments. So this formula is, using this formula, what you need to do is, so at equilibrium conditions, what are the equilibrium conditions? At joint B, MBA plus MBC is equal to 0. Okay, now where is MBA? Where you can find out MBA? From equation 2. This you can find out from equation 2 and MBC from equation 3. So MBA equation 2, you write down what is MBA. MBA, you can see here MBA equation is 225 plus 2 EI theta. 25 plus 225 plus EI theta, not 2 EI theta B. This is the MBA. What is MBC? MBC you can get in equation 3. So MBC you can get in equation 3, that is minus 31.25, 0.8 EI theta B plus 0.4 EI theta B. So MBC minus 31.25 plus 0.8 EI theta B plus 0.8 EI theta B plus 0.4 EI theta B. If you are getting any confusion during this step mix up, you can just message. Okay, so there again. So 25 minus 31. So this becomes, simply remove the bracket, 25 plus EI theta B minus 31.25 plus 0.8 EI theta B plus 0.4 EI theta C is equal to 0. So simplify this equation, minus 31.75, so this will be minus 6.25 EI theta B, EI theta B. So this becomes 1.8 EI theta B and plus 0.4 EI theta C. So this simplify this equation, 1.8 ei theta b plus 0.4 ei theta c is equal to 6.5, and if you take that side it will be plus 6.25. This is your equation A. Take this as equation A. It's equilibrium condition. From the equilibrium condition you have got this equation. From equilibrium condition, this is A, you take this as A dash. Okay, now similarly at joint B you have another equilibrium condition. So there are two unknowns. So two unknowns are there. So you should have two equilibrium equations to find out. Okay, yeah, another one we have at joint B. So for M at joint C, MCB plus MCD is equal to 0. So this is your equation B. So what is MCB? MCB, you can see in the equation 4, you can get 31.25 plus 0.4 ei theta b plus 0.8 ei theta c. MCD can be in equation 5. Yeah, theta c, that is it. So simplifying this, what we have is 0.4 ei theta b as it is, nothing we have, don't 0.5 ei theta b, nothing we have to add, 0.8 and 0.6. If you add 0.8 and 0.6, that will be 1.466 ei theta c. Okay, 1.46 ei theta c is equal to, so 31.25 minus 71, that will be minus 39.86 is equal to 0. So simplify this right, and this ei theta b plus 1.46 ei theta c, if you take 39 this side, it will be plus 39.86. This will become b dash, equation b dash. So solving, so we have two equations, that is solving a dash and b dash simultaneously, solving these two equations simultaneously using calculus, you can solve that. So we have value of ei theta b and ei theta c, ei theta b and ei theta c. Okay, so we get these values using the calculus, minus 2.73 and 27.9. using solving those two equations, a dash and b dash simultaneously, solve two equations, two unknowns, we will get ei theta b and ei theta c value, that is minus 2.73 and 27.29. As solving the by in two simultaneous equation, we will get two unknown values. This is the unknown values, theta b and theta c, 2.73 for theta ei theta b and 27.91 for ei theta c. Use the calculus and try to get those answers, 2.73 and 2.73 and 27.91. Now what you need, after getting these values, what you need to do, you need to substitute these values, substituting these values in equation 1 to 6 slope deflection equation, what we have made in equation 1 to 6. So in this equation, when you substitute, you will get all the final moments. Substituting those two unknowns in this equation, 6 equations, if you substitute, you will get 6 answers. MAB, if you substitute all those values, you get minus 26.36. MBA 22.27, and BC minus 22.27. I told you that summation of the moment should be equal to 0. You can see that MBA and MBC plus minus, you will get summation will be 0. MCB at joint C 52.48, MCD is minus 52.48, and MDC will be 44.85. so this is your the final moments, what you get, final moments at the final joint end moments. So after that, you need to draw what is BMD and SFD. This I'll show you in when we'll have a Zoom class. So how to draw BMD and SFD. So go through these steps and try and find these values. Once you get these values, substitute that value in all the 6 equations. When you get substitute all those values of these answers, you should be able to get these answers. Okay, you should try and solve the problem, and once we come to Zoom class, you can just discuss the answers what you have got. Okay, and we'll draw the BMD procedure for drawing BMD is you need to draw free BMD and then the moment. These are the final moments, end moments, like joint moments developed at the joint. Free BMD is the BMD when we draw both. Free BMD means moment at the center span and at the end spans. Okay, so that we're going to discuss in the class, in the live class. So when we are having the interaction class. Okay, so solve this problem and get the answers, and the whole part is over. Last we can need to draw, only the drawing part is remaining, how to draw the BMD and SFD values. We have all the values. Okay, thank you.